How's it going, everyone? Welcome again to another video on the NeetCode problem solution. This is a series of videos that I'm recording as a way to see how can I apply this data structure and algorithms, these particularly tools in computer science, as a way to solve real-life problems and look at the patterns of how to use them. So, because the methodology here is also from the Nadeep Singh, this software engineer that has previously worked at Capital One and software and Google as well. Now, the idea of this is to, as I mentioned before, be able to be familiar with all of this particular data structure and algorithm, data structure like an array, stack, queues, HashMap, tree, heaps, graph, and algorithms like sort and searching most of the time, but the most common for that. So by looking at this specific roadmap as a way to how you can now use this particular data structure and then see how it'll going to unlock particularly patterns that then you're going to use to solve other particularly problems in your career. So now Nadif actually split this up into this particular way, and I think that's quite convenient based on his experience, because he solved a lot of these particular problems as a way to understand what is the thinking process or the train of thoughts. Well, our methodology here, combined with what he did, is to 45 minutes, in which the first 10 minutes, let me actually put this. Okay, first, so the first 10 minutes is recap of what I have learned, right? Okay. And then you have now 20 minutes to think about the problem, and then to think about the problem and solve it. If we couldn't solve it, then look at the solution. But the idea here is to be able to at least how my brain works and how my brain actually see all of these particular patterns and how they fit together, and also improve my soft skills as a way to, as I going to develop this particularly as a way to develop this particularly problem solving skills, and I talk out loud about the problems, then how can come up with a solution of that, even though that is wrong, because there is not wrong or right. It's just a particular way that is not efficient or not effective than another. That's different. And this is where it comes from, the mathematics, and from brilliant.org. Brilliant.org actually is a very fascinating website, where here in the mathematical fundamental is that look at how now the geometry and the arithmetic, or the art of counting, is being used as a way to create now generalizations, or aka the algebra. And then how now a lot of the time when you think about the problems, see from different perspectives is crucial when it comes to actually tackle a problem. and how now thinking forward by clarifying all the things that you need, or by clarifying or by get all the things that you need, and by thinking backward is by make a list of what are the things. Yeah, you make a list about the things that that are most probable. This is something that I can argue that I have that the fundamentals. I actually have that here on Go on my docs, that I actually take the foundational math here, where I take some of the value proposition of each one of them. So for example, the value proposition of rethink, rewrite, and redraw here is that for every mathematical concept, there is always more to learn if you change how you look at things. So the value proposition is the mathematic perspectives. Changing your perspective is a powerful problem-solving techniques in math. In other words, if you are now in the more emotional realm, there is a time when you stop complaining about it and then you find a way to solve it. You look things from different perspectives. And often the right solution can make difficult problems suddenly straightforward. And now how by thinking forward and backwards is like by thinking backwards, by enumerating all the possible answer, because we're talking about here is the probability, by having a list of all the possible answer, which is thinking backward, and thinking forward is starting. A lot of the time, it's easy to start with what is true. So, thinking forward and backwards by looking at the thing that you can specify quickly and keep all the possibility in mind, you can solve problem more effectively. This is one of the things what we're gonna do here. By looking at the thing that we can specify quickly, you know, quite abstract here. But let's go to put it here. So by looking at things that you can specify quickly, and then keep all the possibility in mind, a lot of the time that's the best way, or you can solve problems effectively. So in this particular exercise here, which is valid parenthesis, which is one of the widely exercise asked in a lot of interview questions, part of the stack here, all right, part of the stack here, nope, we already have this, is like this, right? So let's go to read about this problem, but before that, I just want to make a quick recap of all the problems that we have learned and what is the main the value proposition of each one of them. Contain duplicate, it was pretty straightforward. By using now data structure like set, we can actually get is the we can actually get the unique values in a collection of values. If we don't have that set built-in tools, we can use now by having is a hash or a data structure like a table. We're gonna count each one of those numbers, and we're going to store the number as a key and as the value as the number of times that we have them. Or another way of doing this is that we're going to iterate through this collections, and we're going to, as we do that, we're going to store the value as the key. All right, and as our value is the number of time we have counted. So if as we move on, and if we find any of these value that is present in our hash, it means that this contains, so these collections contains duplicate. Therefore, here you're gonna output the result. So this is the valid anagram is as a way to how you can now work with strings, transforming to an arrays, and then you apply one of these nice little convenient function like sorting methods in JavaScript, okay, as a way to sort them based on the UTF-16 unit code, which is a table that now it has all of these characters, a table of character lists. When you have now, well, all of these symbols represent all of these symbols, and it is proper representation of that. So by transforming that string into a lowercase, because now when we do that, all of those low level letters in the Unicode 6 or in the UTF-16, which is this uniform transform format of character, which is a character set that once we transform it into a lowercase, which means that they're all now in that particular format. So when we take a look at the table, we're gonna see in which order they are present. So we can actually compare to that. So this is one of the nice little thing of the sort methods in arrays from JavaScript. So once we transform that string into a lowercase and then into an array as a way to now sort them to have all of these elements, or in this case, valid anagram, two words already sorted, all right, in a lowercase, then we're going to compare that. There is a convenient built-in function called operators that allows to do that. So far so good. The two sum is also one of the very interesting questions that a lot of the time they actually is being asked in an review. Yeah, where now this is, hey, give me now is the index. Okay, give me now is the index at which this. Okay. Yeah, that's right. So give me now is the index that give me now the index of two numbers that when they add up it match to the target. Okay, so because given these collections, what we're gonna do is using a hash rate as a way to now is anytime we iterate through all of these elements, we're gonna get is what is the number that we need to, or the complement number from the target, and we're gonna store that result in our hash. Why is this? Because anytime we want is to look up our table for that number, we will now know which index it belongs. So what is the index that it belongs? So this is quite interesting because in our HashMap we're gonna store is now the complement as the key, followed by the value. All right. And that's something that, as you can see here, is starting to develop this particular sense of how you're going to represent its data inside of this data structure. Group anagram was another good example, and top K frequent elements and in string encode and decode. And I think that to me was one of the most interesting problems, because not only is something that you can apply in your daily life, because most of the time we want to know is what is the most frequent elements. For example, what is the most frequent days that a particular employee has taken off for sick off day, or even yourself is like what is the most frequent food that you actually eat every day, or the most frequent place that you go, or how many yeah, the most frequent friends you visit, and that kind of thing, you know. What also is the most frequent place that you or the most frequent banks that you're going to retrieve your for withdrawal. This is a very interesting algorithm, by the way, or yeah, very interesting problem, similar to the string encode. The sort different from each one of them is that the typical k frequent most elements is as a way of how, by giving these collections, I want you to give me it what are the most k frequent elements, and it is all about is getting all of the sequence, getting all of these elements, store, and as you iterate through all of these elements, store the number of occurrence, and then now with by building a new array where each one of those indexes will represent is the number of occurrence, you're going to now put all of those elements there, and then you're going to reverse that array, okay, and get is the most k frequent that you need to. That is something mind-blowing, bro. That is something mind-blowing as a way of how you can solve this particular problem, by the way. And similar to the string and the code, where now here is about is representation. What is the particular data that you need to add to a string, or to as a way to encode the data, that when you want to decode the data that you pass to this function, you would know exactly how to get this or how to extract this data out of this. And that's what we use is, for example, to index as a way to navigate through and move around through that string. All right. Probably array itself is as a way of how now you can actually calculate all of the elements except itself, or how to calculate is a product of all of the elements except by that number, by using is a prefix and a postfix. All right. Valid Sudoku is more. It was more like see how you can now is. Well, work with matrix, iterate with matrix as a way to avoid in a particular row or column duplicate value, and also how you can now represent is these 3 by 3 blocks by using is another set that is if the index falls into that position by dividing them by 3, which is after all we use 3 as a way to now split this into 3 by 3 matrix. So once we're able to divide those index, that will indicate to which subset of 3 by 3 blocks it belongs, we can now then store that number and see in a set and check if that is and check if there is no duplicate values. That was another very interesting project. Again, more like something that is finicky, something that is let's see the again, it's a very specific for that problem, like valid Sudoku. I also look at the valid palindrome. This was quite interesting, I must admit. Yep, the valid palindrome. Where the idea here is to a palindrome is a phrase, unlike an anagram, which is a word. A palindrome is a phrase when you remove all of the non-alphanumeric characters, and when you reverse that, you'll get the same word, the same phrase. Okay, so it is the same backward and forward after you remove all the alphanumeric numbers. And I think this is something interesting because This allows us to work is with regular expressions, which is something that a lot of senior developers, I will argue that they don't know. They are not that literal. They are not that uh, uh, that eloquent or that yeah, that they're not that they're not that they're not that um, pros at that. Uh, so what we did is just, well, let's going to examine this particular string and using a regular expressions to only give me those elements that are is a alphanumeric number, which is from A to C, or from 0 to 9. Okay, get me only those that actually match that. And I think that was quite interesting. And then I want to know that as we iterate through all of these characters, I'm going to create is my palindrome, and then I want to after I did that, I want to now is reverse that palindrome. And how to reverse something here in the case of JavaScript? Well, you transform that into an array, and then you now reverse that and transform back into a string like this. All right, and then you use object.is as a way to compare that. You may wonder why this instead of assignment operators. Well, because object.is, unlike the triple equals, object.is is not we check it check truly the value. It check a true equality of this values of these variables here, because now unlike the triple equals, for example, not a number or zero positive or plus positive or zero, or for example, if the result of this give now not a number, it not consider that a triple equal. They don't consider that an equality. Or if both of them are zero plus 0 or minus 0, it doesn't consider that. That's why we use object.is. Again, because we're working with string, that is not an issue. But it's just as a way to now, again, put up practice the soft skills as well as the hard skills, and why we use object.is. Alright, so finally, let's get into the valid parenthesis. Let's get it to rumble. Okay. Let's get it to rumble. Cool. Now, because with the valid parenthesis, the idea here is to giving a string containing just a character, most of the time is parenthesis character, determine if the input string is valid. An input string is valid, an open bracket must close by the same of type of brackets, so they must have an open bracket must close by the same type of brackets. An open bracket must close in the correct order. All right. So, for example, for inputs like this. So for inputs like this is not a valid, because unless you have some parentheses here, this is a valid, and every closed bracket has a corresponding open bracket of the same type. So here, this is the thing that we can specify. This is the thing that we can clarify here. So open bracket must be closed by the same type of bracket. Okay. Open bracket must close. Okay. Open bracket must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So what is the thing that we can specify first here is to, we can now is have a hash, okay, that we're gonna store is all of this opening, okay. So we're gonna, because now order here is important, open bracket must be closed by the same type of brackets. So we're gonna store now a hash here with all of this opening brackets, and we're gonna see if that actually is exists in our stack or in our hash. And because with stack we can now is so the stack pretty much in JavaScript, so the stack can give us is the order in the case of JavaScript, the call stack allows a programs to provide is the order of execution, or in other words, a call stack can give you is or can make a computer know where is currently at, or can make a computer to keep track a program's execution, okay. So because this allows to control, or this allows to keep track is the program execution, is how all of the things are being added or removing, and in particular case we want to know is that all of this, we want to fulfill all of these conditions. Open bracket must be closed, that's right. So open bracket must be closed by the same type of brackets. An open bracket must be closed in the correct order, all right. As well as every closed bracket has a corresponding open bracket of the same type. So because of that, how can we specify is this one, and this one, and this one, okay. So open bracket must be closed by the same type of brackets. The way of how can we specify here this open bracket must be closed by the same type of bracket is that by having a hash, by having a record that we can compare this. Open bracket must be closed in the correct order. Here, if order matters, we can use now a stack as a way to do that. And the other is that every closed bracket has a corresponding open bracket of the same type. So we want to also make sure that all of these closed brackets has a corresponding open bracket of the same type. This is pretty much like this and this one, okay. So first things first, we can is now have a record where all of the opening characters, all of the opening parenthesis like characters, and as we iterate through this string, we're gonna check if that actually contain is an opening character, okay. We're gonna check if that contains an opening character, and if it is, let's going to add that to the opening. Exactly. If that doesn't exist, or exactly if that doesn't exist, let me now add this to the stack. Okay. However, if I found that closing tag is the same value, exactly. If that closing tag is the same value, so if that closing tag is the same value as what we have in our stack, then we're going to remove all of those elements there. And we're going to do the same for all the elements. So the idea here is that first we're going to create a hash. So far so good. That will contain is all of this. And as we iterate through this collection of values, all right, I want you now to check if that is an opening bracket. Okay, if that actually is match this opening. Okay, if it is, all right, let me now add that let me now add that to the stack. And I'm going to do that until I find is a character that is not an opening. If that is not an opening, all right, now I want to see what is this, what is the closing value here, okay? So this is a closing tag. I want to get that, and then I want you compare that the last element here, is that actually match with what we have in our set, and compare that with that value at that moment. And if it is, all right, you can now pop that from the call stack. If it's not, you're not gonna do anything. And once we now iterate through all of these elements in the string, and after that, all right, so the result will be is if the stack is empty. All right, so if the stack is empty, it means that this is a valid one, so proceed that. Let's get into this. So now we have now our opening tag, open to close here, which will be is an object that will contain is this, and that must match. Oh my god! Just a fun fact. Axel Rossmeyer, I think. So Axel Rossmeyer, exactly, mentioned that objects plays two roles in JavaScript. Exactly. So Rossmeyer say that in the parenthesis that objects plays two roles in JavaScript. What does it mean? What is that? That it can be either a record, which is in this case, and what is a record? Well, that is an object that has a fixed property length, whose property names are known at development time, but their values or the value types can be different. It can be a string, it can be a number, it can be a boolean, any of the primitive. And the other is dynamic objects, whose values or whose properties names are not known, and it can be an arbitrary name of properties, but their types are the same. And again, this is quite beyond the scope of this. I just want to mention that this is relevant to TypeScript completely, very relevant to TypeScript. And since we are using TypeScript here, this is how we can say, for example, like this. You say, hey, this will be is now a record or a type, okay, an object of string, an object of whose key are string and string. All right, this is pretty much saying that. Again, this is a type expression here, string and string, but because now TypeScript infer that, and because we don't have any auto completion here, it's like pretty much dull. It's like pretty much unnecessary here, or not useful. All right, so now it is time to iterate through all of these elements here. So because we're going to iterate through all of these elements, we can do is we can use this the iterable protocol cons dot, we can say is the char of s, and since now strings are treated like an iterable, it implements the iterable protocol, which is like a badge to indicate to the for of syntax, hey, this is now implementing is the iterable protocol, which is it's going to produce an iterable object that is going to have the shape of the next, which is a function that is, when we call this function, we're gonna get is the value as well as the property called done, which is a boolean to say, hey, are we done iterating through this collection? If it is, good. If it's not, all right, keep going. So yeah, char, good. And so this might or not be helpful for our case. We're gonna see if that actually is helpful or not. But because now we are in this first element, we want to check if the character at that moment, all right, if the character at that moment, I want to now to look at if that actually match an opening one. You know, how do you do that? By say object that has own, all right, and has own property here is now comparing is this particular object with that particular so what it's doing is this, hey, is this object has own, is this particular object open to close, or you can, another thing is this property, in this particular case the charge is now present as a property in this object to close, all right. So if the char property is present at the open to close object, if it is, good, that's going to now add this to a stack. See, hey, con stack here. Okay, initially is 0, you don't have any element, it's gonna stack it to a stack. Say push the char, right? Good. However, exactly. So if this is an opening, so if this is exactly what we're saying here is that, hey, if this character is an opening, okay, all right, add it to it. However, if it's not, all right, if it's not, what we want to do, so we are assuming that this is now a closing one. So what we're gonna do is, I want you to check if the last element, which is stack.pop, okay, I want to see if the last element here, yeah, I want to see if the last element here I want to see if the last element, which is when it comes to closing, I want to see if that element there okay. I want to see is the exact. I want to see if this last element, okay, actually match. I want to see if this particular elements in our stack, which is an opening, actually match. Okay. Actually match to actually match to what we have in our open to close open to close. All right, I want to see is that actually match to or open to close, which is if this is the if this element if because we're adding all of this opening we're adding all of these opening bracket characters, right? Bracket like characters. So we're gonna check if that last character, okay, when we check in our table to compare that to the other one, okay, because we're using now this hash map as a way to compare that or to keep track that. As you can see here, object here is used as a way to compare that or to keep track or to group or to count. That's something interesting. So if this actually now is compared, so if we get now this element, if these last elements are now what we expect to be, okay, if these last elements is what we expect to be for the next one character, which is not an opening, which is a closing one, which is on the chart, if it is, all right, I want you to now is remove that element from that, stack.pop. Exactly. But I think stack.pop is particularly operation. The pop remove the last element from an array and return the element and return the element. This method changes the length of the array. So which means is this method, okay, array property shift has similar behavior to pop but applies to the first element. The pop method is genetic. It only exists at this value and length. In case you in case you want the value of this to be the same, but the return new array with the last element removed, you can use this. The return value, the remove element from the array. Undefined is array is empty. Unfortunately, by doing that, we are removing that element from there. We are removing that element from there. Exactly. If the element that you pop up from that is different from the character, you're gonna return false. All right. Hey, it's not a valid one. Hey is not a valid one. So now, exactly, hey is not a valid one. We don't want you to keep going there. However, if it is okay, I want you to now remove that element from the stack. And after you do that, all right, if the stack, what we can say is you're gonna return if the stack dot length is equal to 0. I want you to see if you can return true or false. Okay. Return false. Okay. Okay, output false. Expected true. That's quite interesting. So if the first element is this. So if the first element here that we're passing to our collections, if the first element that we're passing to our collections now exists in our hash, okay, I want you to now add that. Okay, I want you to now add that. So if this object has on property here, which is saying, hey, I want you to see if that object, I want you to check if this is an opening, I want you to check if this is an opening, right? I want you to check if this is an opening character, open to close, right? If this is an opening character, all right, good. Let's going to add that to the stack. All right, and I'm going to skip this. Next one, if this is an opening tag, okay, is this an open bracket? Yes, it is. It's actually matched. You can find them as a props here. That's great. Now let's go to add that. But now when it reached this particular case, okay, because now this of course is not an opening, because this is not an opening, it's a since this is not an open character, I'm gonna see if the open to close stack dot pop. So when I remove that element, yeah, it's because I'm removing that element twice, and in my case I don't want to remove that element. I want is to, in fact, is to get that element, is to read that element by saying stack dot length -1. I want to read the last element there, okay, which is in this case is this. If this is an opening character, and is this element that I get in my, is the last element that I get in my stack is an open, okay? It's actually now, when I compare this to the closing tag, is now the same. Is that different? Return false. Otherwise, remove that from the pop. So when I run this, this is supposed to work as expected. Yes, it is. Because I want is to read that element, not to remove them. That's what happened. So when I run this, when I submit this, okay, that's right. Okay. Okay. It was quite interesting. Very interesting. Very interesting. So one of the things that I can come up with this, as well as the memory, 51%. Exactly, key string on the string. And they are comparing that. That's quite also interesting. They're doing this static comparison. And the top element, and that's right. So for example, if I submit this again, all right. In terms of memory, it is, but in terms of runtime, it's not that efficient. Most likely because I'm using is perhaps this, because I'm using is perhaps this. But as you can see here, look at what we are doing here. This is the thing that we can use with our hash. With our hash, we can use this to count numbers, group them, and compare, and use to compare them. And I think this is the pattern here. You can use also map as a way to compare them. Well, actually, the name itself, the map, tells you what to do. And also in the stack, as a way to keep track is the order of this. That's to me is quite interesting. And when you are able to understand how you're doing the kind of thing that you do, wow, all right, that's actually is quite interesting. And how all of these things actually works for that. And how you are going to be familiar with, especially in JavaScript, as a way of how you can do that. And then how you can transform that into one place to another. But yeah. Alright, so that'll be all for this video. Take care. Bye bye.